I like to say that this is my third act as AI research lead at Snowflake. My first act was in academia, where I spent 15 years on the faculty at CMU in ECE and computer science. And after that, I started a company called Truera, which was in the AI evaluation, monitoring, observability space. We ran it for 5 years, and then we were acquired by Snowflake middle of last year. The product is now integrated, part of the Snowflake AI platform, and I now co-lead our AI research efforts. Today's session is about building and evaluating agents with MCP tools. We will have about 30 minutes. So a bunch of folks have already seen what MCP is, but just to bring everyone on the same page, MCP is a protocol introduced by Anthropic, which now has gotten a good amount of adoption, is starting to become the de facto standard, if you will, for agents to call tools and sources. And the idea here is, let's say some company has a bunch of data on Snowflake, and they are building some application on their side over here. Then Snowflake has an MCP server through which there are a bunch of tools that they have made available, and the customer who's building their agent on their side of the platform can access those tools and through them access the data that is on Snowflake. Similarly, Google might have made an MCP server available for data that's on Google Drive, and there's code available through GitHub. GitHub has its own MCP server, and from this ecosystem, if you will, of MCP servers, it just makes it a lot easier for developers and enterprises to build agents that are extensible, that can easily call all these tools following a uniform protocol. And the big advantage here is before MCP and standards like this came into being, if someone was building, let's say with Anthropic model, some agent, then they would have to build these custom connectors, if you will, to call tools to access their data on Google Drive or Snowflake and so on. And if there are N of these agent clients and M of these platforms, it becomes an N cross M kind of complex task to get all these agents calling tools on these M platforms. It becomes more of a, instead of a product, it would be more like a sum, where now there is one uniform way to call tools across all these platforms, and that greatly eases and accelerates the productivity of building agents. The other thing that it does is to make our agent frameworks more interoperable, so that some teams might want to build agents with frameworks like LangGraph, others might be building with more custom frameworks from a Snowflake or Salesforce and so on. But now there's one uniform interface for calling tools, and that just makes it easier to switch and have different agent frameworks work with each other. So that's the 10,000-foot view of what MCP is and what it enables. Snowflake recently built out and released MCP server. And what this MCP server does is it provides a way to access data that's on Snowflake through a set of tools. There are two different tools that we have available through this MCP server. One of them is called Cortex Search. Cortex Search provides a way to search unstructured data. So think of data that's extracted from large PDF documents or emails and call transcripts and so on. Cortex Search is a tool that will help you index such data and then search over them. And then the other tool is called Cortex Analyst. Cortex Analyst is an analogous tool, but to search over structured data. So it's a text-to-SQL tool where a user can ask questions in natural language, and then the tool will translate it into SQL, which then runs over a structured database. So those are two of the tools that are available through this server. The third tool that's available is called Cortex Agents. Cortex Agents provides an orchestration framework where you can ask more complex queries, and the agent itself will decompose it into subqueries, some of which might involve calling out to tools with structured data or with unstructured data. So that's the setup of this MCP server. It's getting a good amount of usage, starting to get a good amount of usage now from customers. So I kind of covered this material already, that the tools are Cortex Agents, Cortex Analyst, and Cortex Search. This does orchestration, search over structured data through text to SQL translation, and then search over unstructured data. So let me walk you through a bit of a hands-on path towards seeing how to build with an MCP server like this and measuring the quality of how well the agent is doing. Are there some gaps? How would you address, evaluate, debug, and improve the quality of agents and associated tools? So in this activity, we will see how to create a health research agent. The health research agent will make use of two data sources. One of them is a PubMed data set, public data set, related to research in health, which is published and available. And the other is a clinical trials data set, which is a little bit further along in the life cycle, where you're looking at actual clinical trials data and seeing what kind of drugs got approved and so on. So in order to do that, there are a few steps. We want to get AI-ready data, and one source for this, for the purpose of today's workshop, is Snowflake's marketplace, which has a bunch of data sets that you can play with. Then you create these MCP servers, set up authentication, and then connect your agent to the MCP server to run a set of queries. So to do this hands-on, you can sign up for a free trial account for Snowflake. So I'll pause here for a minute for folks who have their laptops in front of them to just go to signup.snowflake.com and create a free trial account. All that will be required for this is your work or educational email address. And it should just take you a minute to get in. If you are signed in already with a free trial account, then the rest of the workshop, you will be able to also do hands-on, follow along hands-on. The next step is to get the code. So this is a URL that you can go to get the code. We will also make this available after the session. So let me stay on this slide for a minute. If you want to take a picture of the bit.ly link, this is a GitHub link to a notebook. And I'll be walking you through that notebook, but you can play with it later or even now if you're in front of a laptop. Live demos are always dangerous, so Wi-Fi inevitably fails. So I have pre-run this notebook, but I promise you if you run it again, it'll work. So let me walk you through the steps, starting with the goal. We want to build a health research agent that uses MCP-tools to query PubMed for medical literature and clinical trials database for trial information. So all the information that you need to walk through the notebook is already in the notebook. So it should be easy for you to, later on, replicate everything that I'm sharing. The other piece of software that we will be using is this open source project called TrueLens. TrueLens was a project that we kicked off in Truera about 2.5 years ago. It's an open source project for evaluation of agentic applications, RAGs, and summarization, and so on, generative AI applications. And with TrueLens, what we can do is we can log the execution traces of agents, all the steps that the agent goes through, including MCP tool calls, input arguments, outputs, and so on, measure how well the agent is doing, and then iterate on it to improve it. So maybe before I walk you through the notebook, let me actually get to the climax of the story and show you what a final evaluation looks like, and then we'll come back and go deeper into how we get there. So you'll notice here that there are two different versions of this application. There's a base version and a V2 improved version. The base version is the first version of the agent, along with the first version of the MCP server. And in that base version, we are measuring various metrics. So we have things like tool selection, how well is the agent doing tool selection, how well is it doing tool calling, what is its execution efficiency, meaning is it taking an efficient path in executing the tools to achieve its goal. And then logical consistency looks for inconsistencies in the agent's behavior, where something that it did in the past is potentially in conflict with what it does in the future. And you can see in the first version of the agent, on these metrics, it's not doing so great. Tool selection has this is on a scale of 0 to 1, 1 being great and 0 being terrible. And it's somewhere in the middle, right, on all of these metrics. And then we want to look through and understand why is it not doing so well. And then we want to improve the MCP server so that we get to these much better numbers. So you'll see in the V2 version, most of these metrics get a lot better. Execution efficiency has improved, but it's not quite perfect yet. So our job is not quite done, but we made progress in improving these metrics. So let me show you some specific inputs and outputs of this system and how this helps with the debugging process. So if I click on records here on the left, then you'll see that we ran the same 3 queries. What is the primary indicator for this drug? What are the latest clinical trials for Alzheimer's disease? And then a third question. So these 3 questions we ran through the base version of the application with the base version of the MCP server. And then we got these improved V2 versions with the same set of questions. Now, if I scroll to the left or to the right here, then you can see the output from these results as well as the metrics on these tool selection, tool calling, and so on. So if I look at these metrics, this row in particular looks like one where the metrics were not very good. So tool selection was at 0.667, tool calling was at 0.667, and so on for the base version of the app. So we want to drill down and understand why the metrics were low, right? So I'm going to click on that row. That selects and gives me the full details of this particular execution trace. So I can look at the input, which gives us the question. The question was, what are the latest clinical trials for Alzheimer's disease? And then if I click on the record output, I get this set of results. You can see that there are 6 or so results that are of latest studies that look credible. And there are key trends and so on. Now I want to bring your attention towards these metrics. So if you look at these metrics, you will see that many of them are not doing so well. And we may want to pick one of them and drill down and try to understand what happened here. So let's pick tool calling. So if I pick tool calling and then click on this explanation, that gives me a detailed view of why the tool calling evaluation, which was done using an LLM judge that we built, is saying that tool calling was not so great for this agent with this question. So down here, you can see a full explanation of what happened in the tool calling process. So in the first attempt, when the agent asked this question, the question was, if you remember, what are the latest clinical trials for Alzheimer's disease? The agent called clinical trial search. So remember, there are two databases, two data sources. There's a clinical trials data source, and then there is the other data source, which is the PubMed data source for research results, and the clinical trials is more about clinical trials results. So the agent, and both of them, there'll be two different search tools that get set up, Cortex Search with two different sets of parameters, right? And the agent has to decide which of these two tools to call in order to answer this question. And because this is a clinical trials related question, the agent does the right thing. It chooses the right tool, which is tied to the data source of the clinical trials data source. So you can see that evaluation from the tool selection judge, which says the trace shows a healthcare research assistant attempting to search clinical trials for Alzheimer's disease through multiple locations. And so it's calling the right tool. So that's progress, that's good. But then it also, in the process of calling the tool, just like in computer science, when you call a function, you have to specify the different parameters of that function. When you call a tool call is like a function call. So the agent has to say, okay, I want to call this tool with these input parameters. Now the input parameters for Cortex Search is actually just the natural language query. So what the agent should have done was to say, call Cortex Search with the parameter, what are the latest clinical trials for Alzheimer's disease? But instead, it also tried to have a column parameter that included the disease stage. So instead of giving the tool one parameter, it tried to give it two parameters. And when you do function calls with the function signature, it expects one parameter and you're giving it two, naturally it'll fail. At that point, if you as a developer were doing it, you would notice it and we would say, okay, something's wrong, let me check the signature of the function. And in future, I'm only going to give it one parameter instead of two. But that's not what the agent does. It does the second attempt. It just changes the parameter. Now it's saying, here's the natural language query, but includes status in the column. So it's again calling with two parameters. So it fails a second time. At this point, you would think it has learned, but no, it will do the same thing in the third time. It's just changing the name of the parameter. So it keeps failing a bunch of times, fourth time, and eventually, on its fifth attempt, it succeeds. So that's why it gets a low score for tool calling, because it did not call the tool with the expected correct set of parameters, and the tool call failed 4 times. Then it figured it out, and then it did it correctly. So if you look at that final overall assessment, well, the grade was not a failing grade. The grade it received from the LLM judge was like 67%, like 2/3 of the way there, because it was persistent, and the judge is kind of kind. It's like a gentle teacher who's encouraging of the student, who eventually figured out the answer, but along the way failed 4 times. But this costs us money, right? Because it should have been doable in one go. It took 4 goes. So that's the kind of the workflow where you assess these with these LLM judges, understand where the gaps are, and then that in turn suggests some failures. When you set up MCP servers with these tools, you can see some kind of common errors for tool calling. One could be that there are tool calling errors, like either the agent might use the wrong query or use the wrong parameters for the tool. So in the running example that I gave you, the agent was using the wrong parameters for the tool. But you could also have other forms of failures. And then for tool selection, the agent can sometimes use its internal knowledge instead of tools to answer questions. And that leads to hallucinations. It can also select the wrong tool. So in the running example, the failure mode we had was this fourth failure mode, but we have seen examples of other failure modes as well. And then this suggests things that you want to change in the MCP server in the way these tools are described in order to close this gap. So what we have, the kinds of things is to have a map, is to map key use cases to tools, provide instruction both when to use and when not to use each tool, and also be explicit about the tool parameters. So I was showing you this row before, which was the base MCP server with this question. The corresponding question is here with the improved V2 version descriptions. And now if you look at tool calling, it gets a full 1 score. And now it invokes the clinical trial search tool in response to this question. The tool was called with the appropriate arguments, including a limit parameter and search query, and it gets it in one shot. So instead of having to do this 4 times, the agent is now able to get this in one go. And I'll go back to the code and I'll show you in a little bit like what changes we had to make in the tool description that got us to this point. But one of the biggest challenges when you build MCP servers is to make sure that the tool descriptions are on point, that they're sufficiently informative so that when agents are getting tasks, they can select the right tools in the right sequence to solve those tasks. I mean, this agent can make multiple tool calls, right? So this is a typical React style agent where given a query, it decides based on the query which tool to call, then it gets the response, then it reflects on it, then it can make more tool calls. Sometimes it'll make multiple calls, tool calls in parallel. There is kind of an orchestration style view here. So this is a simple agent for the purpose of illustration, so we can go through the whole thing. But we have built quite complex agents at Snowflake. We just released an agent called Snowflake Intelligence, which takes very complex queries, decomposes it into parts through an orchestrator, which then calls various tools like text-to-SQL and search, and there's also like coding, Python coding tools that generate charts and so on. Your question about how do you evaluate it? So we recently introduced this framework called Agent GPA. So we have some students here who want their GPA to be high. So we have also created this framework for measuring an agent's GPA, and there the word GPA means goal, plan, and action alignment. So what we have observed is that a lot of agent failures occur when the goals, plans, and actions of agents are not well aligned. And so for each of those categories, we have evaluation metrics that are implemented with LLM judges, and these can be measured very effectively. And we have done benchmarking showing that the agreement with human annotations is very high. And we have also applied it internally to Snowflake Intelligence with success. So this is in open source. If you look for what is your agent's GPA, you'll find a paper. These judges are released as part of TrueLens. And I did a course with Andrew Ng on deep learning AI called Building and Evaluating Data Agents, which is a 2-hour course that lays out this framework. That's our current thinking on the best way to evaluate and debug agents. How does the agent know which tool to call? So There are two parts to that. One is the tool description itself needs to be sufficiently explicit about what this tool is doing. That's one piece where there is, it's a knob, if you will, that as a developer, as you're building an MCP server and you're writing the descriptions of your tools, you have to do a good job of being clear about the purpose of that tool and how it is different from the purpose of the other tools that are also near it. So PubMed versus clinical trials, for example. The other part of it is the prompt that you give to the agent, right? So those are the two sets of knobs. And for this particular agent, I can show you concretely what the difference is between the V1 and the V2 tool descriptions and agents that help the agent get better. But in general, this is also like a core task for building effective agents and effective MCP servers. Now what I'm showing you is a evaluation and debugging workflow which builds on this agent GPA framework that helps with this problem. We are also experimenting with automatically optimizing it. So right now the workflow is a bit more human in the loop, where I looked at the evaluation and I said, okay, this tool call repeatedly seems to be using 2 parameters instead of 1. So I better make the tool description much more explicit to say that when you call Cortex Search, you just need to give 1 parameter as the query, which is the natural language query, and nothing else. But this is also the kind of thing that LLMs can help with automation of. So there's a body of work around optimization of prompts and tool descriptions that we have been building on that we'll be ready to talk about publicly pretty soon as well. What if the agent needs a tool that's not in this list? Can it come back to the user? So it depends. So let me try to kind of factor that problem a little bit. What I was focusing on here is a bit more around how do you set up an MCP server to be effective? What's an effective MCP server that agents that are externally being built can effectively use? For that purpose, it's a more scope problem than the one that you're asking for. At Snowflake, we have 3 tools that we want to make available to anyone who's building agents that need to access data on Snowflake. So let's imagine some big bank is building agents on some platform on their side, but they have a lot of data on Snowflake, and they want to access that data through Cortex Analyst or Cortex Search or Cortex Agents, right? In that setting, the set of tools that we want to make available, that agent at the same time might be making use of other tools, right? So they might be talking to Salesforce for their CRM data and so on. Now, nevertheless, the question that you're asking is still very interesting, which is more of like, how do you design these agents to know what they don't know, if you will, right? So let's say that you gave this agent a task which involves doing some math. Used to be the example I used 2 years ago, but now the reasoning models have gotten really good at math. They don't necessarily need tools to do math. But let's say it's another data source, right? That is something that the model itself cannot do. But one thing that models do, for example, is, and this is to guard against hallucinations, is if you ask it a question that it is not confident about, then it should come back and say, I don't know the answer to this question, maybe I need another data source. So for example, and I have that slide on other talks, but 2 years ago, this was 2023, at that time I was still at Truera, and at that time when I asked Claude 2, who are the founders of Truera, it gave my name, and then I had 2 other co-founders, and then it put 2 other random people's names there, and then it said we were founded in 2014 instead of 2019, and that we were acquired by SAS in 2019. So it was all a lot of made up stuff. And then now when I go back and ask, and if you're in front of a laptop, you can go to Claude AI and ask who are the founders of Twilio, it gives exactly the right answer. And the difference now, what's happening is, internally, what it might try to do is to run several times and see if it's always getting the same answer. Before it starts calling external tools, it'll run the same query through itself, say 10 times, and it'll look at the answers and see, are they consistent? If they're largely consistent, then it says, okay, I actually know the answer to this question, and I'm going to just spit that out. If it doesn't know the answer, then it'll try to figure out how to get this answer. For this kind of question, it actually does a web search. When it does a web search, it finds some news article about our acquisition, and then it cites that article and summarizes it, right? So there are a set of pre-built tools that I mean, in some ways, these model APIs have become agentic now. It's not just the model. There is actually an agent behind the Cloud API that has access to a whole bunch of tools, right? So it'll try to use those tools to answer the task to solve the task that you're giving it. And we have to think of I would love for you to come up with an example, maybe in the next few minutes while we are still in the talk, of what question you might have to ask that it cannot answer given the set of tools it already has access to. If it doesn't, then it should come back and say, I don't know. Maybe if it's some proprietary data, right? Like if you ask for your company, there is some proprietary data that's not available on the web, but will become available, let's say, through some securities filing in 3 months. If you ask that question, it should be able to come back and say, I don't know the answer to this question, but maybe if you give me access to this kind of data, I'll be able to. But I don't know if it'll do it. You can try it. But hopefully that gives a more general view of what's going on. Cool. So this is my example, right? Remember, I was saying who are the founders of Twilio. This is with Cloud 4. This is what it comes back with. And one way to address your problem is to have citations, where if we insist that whenever the agent comes back with a response, it cites the source. So in this example, when I'm asking who are the founders of Twilio, it did some introspection. It realized that in its internal parametric memory, it doesn't have that information in a high state of confidence. Then it did a search on the web. So there are these 10 results that come from it. And then it assessed, of these 10 results, which ones are most relevant to the query. And then there was this news article about the acquisition of Twilio by Snowflake. And it cites that in constructing the response. So that's one approach, that this is called groundedness evaluation. And having citations and groundedness evaluation is part of the answer to that question. For every task, it's hard to have citations, right? Because think of reasoning tasks. Reasoning tasks, like if you give a complicated math problem, then you can't just, if it's a copy of a problem from another textbook or something that it has read, then sure, it can cite it. But often it has to figure out a new problem, how to solve it. So in that setting, instead of a citation, there has to be like a reasoning step. So I was talking about logical consistency earlier. Logical consistency is like a generalization of groundedness, where instead of just looking at citations, it's looking for consistencies in the reasoning process, or trying to spot inconsistencies. I don't, right? Like the groundedness framework does not check if the source is fake or not. I think these are somewhat separable problems where you want the groundedness evaluation to be relative to some source, and then there should be some other mechanism to assess how trustworthy that source is. And for that, there has been other bodies of work that has looked at that problem. Like if you think back to the early Google days, PageRank was one algorithm for measuring how influential a web page is. Around that same time, late 90s, there was the hubs and authorities work from IBM Research, which was categorizing websites as hubs and authorities. And authority has lots of links pointing to it, and a hub has lots of links that it points to. And then you have some kind of weighted fixed point computation over the graph of the internet. That's one kind of technique, but there's also a lot more there. But those two sets of things have to be combined. It's a hard problem. API discovery, in some ways, the goal for MCP was to provide a uniform protocol for across, like the challenge with APIs is that everyone can come up with their own idiosyncratic ways of defining standards for how, like the signature for the API. MCP tries to make that uniform so that everyone knows how to call tools with the MCP server. So it's more like a standardized protocol that makes it uniform to call lots of different types of APIs. So execution efficiency is measuring, given an execution trace, was this the most efficient path that the agent could have taken in hindsight to achieve that goal? And that can help spot inefficiencies, which you can then feed back to the agent orchestrator so that it can learn. So there's several different kinds of techniques to improve it. One body of work is on automated prompt optimization that can help the agent learn which traces are efficient, which traces are not, or given a set of traces where it's annotated by humans that this path is efficient and this one is not, then the algorithm, the tool will automatically adjust the prompts so that it pushes it towards taking efficient paths rather than inefficient paths. Another set of techniques is reinforcement learning, where again, similarly, if you have execution traces which are marked with a reward at the end to say, hey, this was very efficient, so I give it a reward of 1. This was very inefficient, so I give it a reward of 0. This was somewhere in between, so it gets a reward of half. And you get lots and lots of these traces, and then you train the model, you train the agent with the orchestrator of the agent to tend to take more of the efficient paths. So both of these sets of techniques have been relatively successful. It's not a solved problem yet, especially for long horizon tasks where the agent has to do many, many steps to get there. But if you have played with the coding agents like Cloud Code or Cursor, they're getting quite good at it. And a lot of it under the hood is reinforcement learning. I do encourage you to take this course on building and evaluating data agents, where I talk about the agent GPA framework. A lot of the questions here have been around evaluation and optimization. For MCP, maybe there's a way for me to share the content, the pointers to the notebooks. Perfect. And then you can just play with it. It's not hard to play with the notebook. I think the conceptual conversation is in some ways more harder to get from the notebook. So thank you so much.
So thank you much for coming today. This is a bigger crowd than we expected. Super happy about that. So here we already did the Snowflake presentation. We'll do a quick intro to Agentic Web. That's about 5-10 minutes presentation. Jumping in a little bit, like why am I here kind of thing. I'm doing Matchwise. Matchwise, if somebody asked me the most smallest version of the thing, it's infrastructure and properties for the Agentic Web. And specifically, we're automating transactions using deep research and the last mile of P2P agent transaction resolution. And if that's all Greek to you right now, by the end of the talk, you'll know what that means. So that's our goal for this. For the requirements, just walking through this kind of fast. This is mostly for tomorrow. Laptop, of course. If you don't have a laptop, feel free to team up with somebody around you. Look around you, see who you can work with. On the software side on your laptop, kind of all the typical stuff you'd expect. Git, of course, you're going to pull down a repo. Python, I think 3.12 is the current one. UV, we talked about it earlier today. And Cursor, we'll be doing some stuff in Cursor. It'd be great to have Cursor plus a license up and running. On the repos we have running for the demos, we are using OpenAI in there. You can configure for other ones if you want to, but we know it's already set for that. So if you have an Open API key, it'd be fantastic. For the clone repos, we have this one here. It's the AI Alliance one, AI Agent Workshop. So let me actually go back in 1 second. We'll give you a QR code, and you can scan to get this worksheet here. So cloned repos. And then a fun part about this is you came to this event, you're coming for knowledge, but you're also coming to meet people. And there's some special people here who will move your career forward. You should find them today. And so we have this worksheet, which I've used a lot of our startups, and it says, what are you working on? And it's based on Jeffrey Moore's positioning worksheet from 25 years ago. But it basically asks you a bunch of questions, gets to know you, and we can use that to build a set of data we can use for matching, which is kind of fun. So we can talk about that too. But let me go back really fast here. If you guys, whoever wants to grab that QR code, if you can scan it, and we'll pause on that for a second. And that's this whole slide deck here. So you can follow along, jump ahead, go back, whatever you want to do. That also has details for the code, the repos we're going to be looking at. So I'll give you guys a minute on that one. And also, this is interactive. So anytime, raise your hand, ask questions, anytime in the whole presentation. No problem on that at all. And like I said, last thing is we don't know how far we'll get today. Whatever we don't do today, we're going to do tomorrow morning. So again, another 30 seconds on that one. I'll jump up into the slides. So I think, I saw the phone. I think we're good to go. So walking forward, so for the workshop, what we're doing is really want to make this hands-on, although because some people don't have laptops, we'll talk through it today mostly. We'll do hands-on tomorrow. The 4 things I want to cover are, one is deep research with MCP Agent. It's one of the tools we're going to bring up. It's really about agent orchestration, and that was part of the talk earlier today, and you've heard a lot about that, and specifically with MCP-tools. The second workshop we're going to do, or section we're going to do, is finding synergies. And that's really the prompting stuff, saying that if I have a corpus of data, wherever that data lives, how do I prompt to get the larger set of data into a smaller set of data, and then how do I prompt that smaller set of data to discover synergies? And specifically for you guys here, is like, who's that person you should meet here? So we'll talk all about that. Going into tomorrow, likely, is establishing identity. And that's one of the big things. If you're only doing an agent, you're on your computer, and you can authenticate human-in-the-loop kind of fun stuff there. But once agents start operating on the internet independently, they need to establish identity. And how does that happen? And it's a nascent state right now. We're developing it. So we'll talk about that tomorrow. We'll show some examples. And one part of that actually is decentralized authentication. We'll talk more about that tomorrow too. And then last mile, I think, is really interesting. We'll talk much more about this in a few minutes. But it's the last mile of agent-agent transactions is how we can use conversational AI to find resolution for transactions, to determine whether you want to buy the car, or rent a place, or make a purchase, or be hired somewhere. It goes on and on kind of thing, any transaction. So those are the workshops we're doing. This is a deeper detail. We'll skip past those right now. And now we're going to talk about the Agentic Web for a few minutes. So we're really at the dawn of the Agentic Web right now. $1.5 trillion is spent just this year alone, 2025, building AI for everybody. And one of the key takeaways from there is it's giving every one of us, giving every one of you, every business, every government their own team of agents. And what happens when they all start talking to each other? The Agentic Web is formed when an agent from any person or business or government can transact with any other agent from any business, person, or government. It's this huge web of agents. And so it begs the question, what are transactions? There's a fairly obvious ones out there, the tangible ones, usually exchanging something that costs money. It's operational stuff, salaries and wages, down to people, housing, transportation, running the Uber, buying food, all that kind of fun stuff. That's fairly straightforward. I think it's interesting, though, is the intangible ones are very, very important as well. It's literally scheduling a meeting with somebody here. If I can accomplish that, resolve that we're meeting tomorrow, that's just valuable for us. For sales, it's just transacting a meeting to talk to somebody is mainly valuable. Information exchange is great. Obligations, a lot of phones there. Attestations are a big part of verifying credentials. And then last thing is reputation. Is it how do you go across and figure out somebody's reputation based on what's on the Agentic Web? All this fun stuff here. Markets are a great way to get there. They efficiently facilitate transactions of goods and services. We've been doing this for a very, very long time. Traditional transactions, this is an example here using markets. And the idea here is very traditionally is that somebody goes in, drops some data somewhere, maybe some data is public, maybe some private data, and they drop it into a market of some kind. It could be your LinkedIn, your Tinder, Craigslist, Luma, it could be eBay, it could be a whole bunch of places there. And that market is going to hold on to that data. And somebody on the other side is going to drop something else in there. It could be a query against it, it could be something they're selling. And what happens is that market tries to figure out who needs to talk to who. And once it surfaces that, it's going to let both you guys know. And traditionally, you go back to the human part of this thing is you'll say you're buying a car, renting an apartment, what have you, you would have a conversation with somebody. And what's happening right now is that's all done by humans right now. We're lacking automation on that. So the last mile of transactions is disclosing more information and convincing the other party to close the deal. The classic thing when you go in an interview for a job, you're going to talk about a lot more than is on your LinkedIn. So if you look at what's happened in the last few years, like everybody's mentioning, is there's so much stuff happening right now. I'm not going to read this whole slide through, but we have the Agentic Web coming up right now, which is pretty amazing. The key takeaway there is everyone here is going to get a private army of AI agents to do their bidding. Deep research is a big thing right now. We're talking about that more later. But it's not just one model running one inference to get something out. It's team models, a bunch of code, figuring out how to get from here to there. MCP, we talked about in the last presentation, was fantastic. A2A is the other side of that, which is agents to agents talking. It's more conversational typically. And the last few months, a lot of development on all the payment protocols. So the same thing is if you can go through, come to some resolution with somebody, or your agent comes to a resolution, how do you actually do the last bit, which is actually transact with them and make the payment and get the goods. So all these here, I won't go in depth on those right now. When you put all that together, you land on a page like this. And this is where it's really fun, and this will drive the other stuff we're talking about. So at the top left, if you look up there, it's somebody sources data from somewhere. It could be that you have decided to share your personal health data with a device, then collects that health data together, and now you have this bucket of very valuable information. It could be you going and typing in a profile. It could be anything where you gather data about yourself or some product or good or company, and you're going to put that somewhere. And that somewhere is in data stores, for lack of description. There's protocols like Solve that give you personal data stores. There's traditional databases. You can go to LinkedIn and add data there. It's all these places you could put this. What gets interesting is wherever you stored your data, you hand it off to someplace, and a market's the natural place for that. So now I have 3 examples of markets there. 2 of them kind of fun little graph things. We're getting a lot of attention in the graph space right now, but it also could be traditional SQL databases. There's a lot of great services out there for storing this. When you put your data in a normal, like what we call traditional marketplace, somebody goes, and this is like 2A part here, is you go and you query it, and you say, I found some stuff, and you look through the list of things you found, and you decide to go buy something. It's like an Amazon experience. But what gets really interesting, this popping up, just this year, is the deep research part. It says that instead of you being informed as a person about a set of options, is let's say that you hit a go button on a set of researchers, the deep research AI agents, and they go hit the markets for you. They might hit multiple markets. They might gather this really complex data together and start making heads and tails of it. And that's where it gets super interesting. So where the arrow is on that one. So you could take the results from a deep research work and say, okay, it looks pretty good. I'll pick from these options it's given me. So that in itself is really powerful. But the last part I think is really, really interesting is talk about the last mile of matching. And the last mile is where it says, you know what? There's a bunch of data that's not in this marketplace. There's not a bunch of data that I wasn't given yet. The person has this data. The agent probably knows it. Why don't I have a personal conversation? So you can fire off one of your agents, go talk to one of their agents, and now each agent represents each respective party, and they will have maybe a very candid conversation. Each one start disclosing. Model my agent's using right now, the amount of compute it's using, isn't good enough. I'm willing to pay more money for it. And the analogy I usually use is things like lawyers. If you want to win a case, you hire a very, very good lawyer, but you pay for it. So in the future, you probably have these agents which will go out hunting for stuff for you. They will find opportunities, and at some point, it'll be a lower level agent say, I need to get more horsepower on this, and I will use more inference, hire a better agent, and take over the transaction and wrap it up. And then in a little arrow here, the very, very last part is once the agents hit some kind of resolution, they'll notify their humans on both sides or whatever it is, and that person will probably come in and approve the deal, whatever it happens to be. So that's one here. One of the fun takeaways in this is that if you look at this chart here, it's green is the MCP arrows. It looks like MCP is going to run a lot of the agentic web. It makes a lot of sense. Like as mentioned before, it's a lingua franca for agents, which is amazing. And so we're now enabled. We now have an agentic web that we can do transactions like this. Okay, cool. Okay, a question down here. Oh, this is the great question. You hear this all the time. People are, what are agents? There's a gazillion definitions out there. The one I like mostly is it uses inference. So that's kind of the really simple one. Is if in the course of it executing its thing, it uses some intelligence as opposed to like a model of some kind, whether it's an LLM or something else. That's kind of the most simple one. The one you hear a lot is autonomous, which is kind of a fuzzy one, but the notion says that I'm going to let you do something. I will give you some kind of a goal, and you figure it out. And that's kind of the fun one with the models, or the MCP stuff we were talking about earlier, is that I will say, hey to the model, here's a bunch of text to prompt whatever I want. Oh, by the way, here's a bunch of tools for you as well. What do you want to do? And it'll do a couple loops in there and come back and say, these are the tools I want. But that's kind of neat because prior to this, the engineer would write the code for that. But in the new world with autonomy, it'll just pick the tool it wants. Heard a talk last week by the guys who wrote MCP Agent, which we'll be talking about later. And they brought just all these really neat things that happen these days as you get more and more autonomy, which is neat. One of the things they were arguing is that you probably shouldn't even tell it what tools to even use, or you give it a set of tools, but you don't describe the meta tools. It'll go off and it'll actually build its own tools, which is really neat. So if you have the ability to actually generate on, that's pretty amazing. And then another part in here, maybe we'll talk about this later, is the notion of like how you naively would tackle a problem. Is you would say, let's think about the problem, let's make steps to the problem, let's follow the steps and get an answer. And what's really neat about this autonomy of agents is they'll say, by third step, every step I'm reevaluating if I'm taking a good approach. And it actually might rewrite the rules as it's playing the game, which is pretty amazing. So that kind of autonomy, I think, is agentic, if that's a good long description on that. So I think I probably haven't got it. But the last mile of this transactional stuff is not cooperative, which is really interesting. Because we're really used to that right now, where we are used to matching systems where there's a single matching system and it tells you who you match with, which I don't think is in reality. In this new version of agentic transactions, is each party gets their own matching agent. And so the other side might like you, you might not like them, or vice versa. So the point is it's adversarial, and both parties are trying to get something different. I'm trying to pay very little, you're trying to make me pay a lot. That kind of fun stuff. So here's a fun little drawing for this. This is an apartment example, and we've probably already seen a bunch of drawings like this already, but the notion is on the left side there with the guy, is he's going to hire an agent, which is really something over a whole army of agents. And they're all glued together with A2 and MCP, and they do all their stuff. And at some point, his agent is going to jump the fence. He's going to leave his infrastructure, go across the wire, and find somebody else, probably through a market of some kind. And that person's agent over there is going to be trying to get what they want. And in this case here, I think it's like, the woman's saying, I want to pay as little as possible and maybe not tell them everything. He's saying, I want to rent as much as I can to the right person. And so, so that's the future of this stuff, is really having two agents transacting with each other. Talking about the company I'm working on a little bit, Matchwise. So there's a gazillion things you can do with the agentic web. Our first vertical right now is bringing people together. So we're doing business and social networking. And this is kind of a teaser of what you could get to. Like when everything fits together, this is what it'd look like, is you'd open an app up, it would just know who's around you, and it basically have already pre-talked to everybody who's interesting to you, and then render some kind of opinion. And in this one here, you might just say it might be a gold star. In this case here, if you have half a gold star, it doesn't count. Full gold star means both parties like each other. And it's a signal that I can walk up to a person and have a conversation with them. It's not going to be weird. What's fun about this also, and we can demo this stuff later too, is like, you might wonder, why do we match? And the fun thing with this is we can actually dive down and look at the conversation between the agents and see why they came to the conclusions they did. So that's a teaser. If you guys want to see it, we can show it off tomorrow. There's that thing. So let's start the workshop sessions. Actually, why don't we defer this until later in the talk if we have time, and then we can get people paired up. If you, in the meantime, want to work on your laptop and get some stuff ready, just make sure you have Git, Python, UV, and Cursor, your Open API key, and clone the repo if you can. That'd be a good start. So let's jump forward. So now we're getting to code now. This is the fun stuff. The first one's agent orchestration and MCP-tools. You've already touched on that a lot. Our goal is we're going to collect AI Alliance member data. So we have, I think, I forget if Dave's here, we have 180 something people in the AI Alliance. And I also extended this, this tool to collect data from the sponsors for this event. So we have all of them as well. And also anybody who had gone and filled out that North Star worksheet, you can actually go publish it in the marketplace, and you get all the attendee data as well, which is kind of fun. But the point is, we have a tool here that's going to collect the data. Let's just join the code and prompt reviews next up. Yeah, bingo. So if you've cloned this, and I'm not going to, we're not going to slow down for this right now. In that repo, there's a little, whatever, the readme instructions. Let's see. Cool. So the way I normally do things, I use Cursor, whatever ID you like on this one. But the one you want to go to is you want to go to the Harvest AI Alliance Network directory. And again, we'll do this afterwards, and we'll walk through in person on this. But the point is, in that directory, there's about 4 files that are interesting in here right now. And we have the main file that runs, the main.py. Inside there's MCP app. We'll talk about that in a second. There's fetch, which is a tool. We'll talk about that a little bit. We have a summarized prompt instructions, which says, hey, this is how I want you to do your thing. And then lastly, I just plugged this in. I did the member URLs.txt list of members in there. So let's pop over really fast on this one. So in this one here, let's see if I can read this a little bit. So the main.py is where I'm on right now. Beautiful. And this whole file here is pretty dinky. And that's the entire file. That's it. And so one of the important takeaways from this is that we talked about Alleycat this morning. And Alleycat took a certain approach to harvesting data on the internet, and it went through and it used I forget, it used fetch, pulled pages. I think it used Beautiful Soup, I think was the API, pulled them in, grabbed the full text of every website, and then took the full text of the website, it chunked that data, and then it shoved that into a database, into a RAG. And so that's one way of doing things. It also is very manual. It used this manual programmers decided how Beautiful Soup should process the links and pages and walk them through. What's interesting on this one is I don't have any of that in here. I simply gave it, I said down here, on this little part here, I said, hey, use fetch. So fetch is one of the tools in JavaScript to go off and grab pages on the internet. And that's the only tool I gave it. I didn't give it these other libraries like Beautiful Soup. And this is the entire prompt. So this kind of fun part here is instead of going to Beautiful Soup and say, here's a starting page, I want you to walk all the links, grab as much data as you can, convert that to Markdown, what have you, I just said, you're an autonomous search agent or a research assistant. Here's a URL, crawl the site. That's the entire instruction. And it just goes and figures it out, which is pretty neat. And then in here, like instructions, I said follow internal links, extract factual details, and that's the fun stuff in there is constraining what it's going to get. Distill into concise, well-structured summary. A lot of times it'll elaborate very happily, so you have to constrain that. And then pull some other stuff here. And what it does is it actually, with each URL, it'll actually go put together a plan, figure out, it says, oh, I have this fetch thing, I can go fetch web pages, and it just starts digging through websites, through a single website. And so I didn't have to write any of that code, it just figured it out, which is pretty neat. There's a side warning on here, as I was running this last night, and I think like a $30 bill from running this. And so the problem is with the 47 million tokens to do this. And so the thing is, again, when you have a well-programmed, concise set of code, it'll be very, very efficient. And that's one of the risks of AI is AI will happily do many, many things, but it also might use a massive amount of compute to accomplish those things. So that said, this thing here, we've got the prompt. We talked about the very simple program. Let's go back to main.py for a second. And so in here, we have the pieces there. We had fetch. Somewhere down here, I have the prompt. I grabbed it. And then I basically just say, I walk the URLs. And basically down here, I just say, so generate. So all I did is I basically plugged that prompt in, plugged in a URL, gave it fetch, and it just figured it out. And what it is, I took the answer back, just a big chunk of text in the answer, and I just write it to a file. And it just rinse and repeat, does it over and over again. And so what you end up with here is you end up with, in this case here, I have a data directory, I have member summaries, and let's just look at the first one here. And so this is a result of this. It went to this website, whatever this one is, acceleration.utoronto.canada. And this is what it came up with. And the question with all this stuff is, does this seem reasonable? And also, I'm not saying right or wrong anything here too. It's like, this is a very small set of data. Typically when you RAG stuff says that I have way more data that I can put in my context window. With my context window, also I get charged for having a larger context window, of course, and there's limits on context windows. And so you can take the approach, earlier on we go and we pre-filter down the essence of the site and pull it into a document like this, which easily fits in context. or you go and you drop in RAG and pull it that way. So different solutions here. So that's what this does here. It just goes across, builds these. We'll talk later about how to make these prompts better. Let's hop over really fast. So that I think we covered that one there. So now the fun thing, you've got this basics here of this is using agent orchestration framework, using a tool, using a prompt to drive it, doing very little programming, and basically having the computer figure it out for you. Uses a ton of tokens in the process, but it ends up with some chunk of data that's kind of useful for you. So one of the things I like a lot is Anthropic came out with an article, I don't know how long it was 9-10 months ago, and they talked about patterns for agents, which is really cool. So I'm going to walk through that with you guys right now. And it's like 6 or 7 patterns here. But this is kind of fun stuff where in the old days meaning like 2 years ago, is that you have an LLM, you'd build some context, you shove it into the LLM, you get your generative, your tokens kick out, and you get some kind of an answer, all that fun stuff. And now we're saying, let's actually take multiple LLMs and glue them together. Is all the early Lang chain stuff and all that fun stuff. And so there's, again, like 6 patterns here, so we'll go through them right now, just to give you some background. And also, all the orchestration frameworks, MCP agent, for example, supports these in code. So you can say, I want to do this, 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 glue them together with these patterns and have it accomplish stuff for you. So the first one here is prompt chaining, classic Lang chain stuff. And it says you decompose, instead of asking the model one big thing to do, which it tends to do pretty, not as great at sometimes, we're saying decompose tasks in a sequence of steps and have each LLM do a smaller step, and you actually might use even different LLMs for each step. And so, so each LM, processes the output of the previous one, and there's the fun thing here of also gates. You might say along the way, this doesn't look right at all. I'm gonna abort my whole effort right now and just get out. Or you might have the answer you're looking for. But this is one of the classic design patterns here. Routing is another fun one. Routing basically says that I have an LLM. I talk to it. I give it some stuff, and on the output side of that it says, who should I talk to next? And again, you might have multiple LLMs out there. You might use ones for lower cost. You might use ones that are specialized, or ones that are fine-tuned, or what have you. So again, you can have it pick the next LLM in the chain to use. That's a fun one. The parallelization is fun, and I did not do that on the example we gave here. Actually, kind of like old-fashioned, I kind of wanted to see it run. But we could have taken that single call and parallelized it and said, do them all at once. And it could have ostensibly gone off, if I had the bandwidth and all that kind of fun stuff, it could have done all 100 at the same time. Next up is orchestrator workers. And so this one here, let's see. Yeah, so the same thing here. This isn't picking from one routing. This is having them all do work, but it's all doing different work. And so same pattern again, relatively straightforward on this. And this is the fun one we're getting into a lot these days. I know people who play with Cursor and all the other IDs out there, it's pretty fun because they will go through and they will generate answers for you. And as they're generating answers, they're actually evaluating their own answers. And it's like they're talking to themselves. They literally are talking to themselves. And they'll look at it and say, no, let's back this up. Let's reverse all the code that I just put in there. Let's take a different pattern on this right now. I think maybe for the people who are doing engineering all day long, you see this all day long in your tools like Cursor. But being able to evaluate and back up on stuff is amazingly useful. So that's kind of wrapping up on that one there. Let's see. So this one here, we can do this later on if you guys want to do it by hand. But this is the same framework we were looking at a few minutes ago. There's a command in there. It says the main.py, of course. When you run it, let's just step number 1 here. When you run the thing, it'll go off. It'll do that harvest, the code we just showed you, and get everything and drop it into your into that directory. It tends to be pretty slow. It took me probably over an hour to do this on my computer. And also, I ran across sites like some sites might think that you're trying to DOS the attack or DOS the service. So they'll actually maybe honeypot you. So I had some things where it went to a site and it just got stuck forever. It just would not respond to my queries. And so some of those I just took off the list here. But anyway, you run this thing, you go to the website results, and then we already reviewed the prompt down here on step number 3. Whoops. And one of the questions for later, when we look at this stuff, when you start diving into the code, you see, did I like how it summarized the website? And would I want more of an answer or less of an answer? And so that's an exercise for us here, because right now, ostensibly, it's pretty simple. I went through, I did one prompt. One of the things that AI is really good is generating prompts. So I took my one kind of crappy prompt, I said, make it better, and made it better. I bet you guys can make it much, much, much better. And so that's a 3B here. I also have another script here. If you guys want to, you can do the, it's called a North Star worksheet, where you fill out something talking about your startup or your company. it'll summarize those things as well. And I have a matching service, and this script number 4 will actually pull all the summaries from the matching service as well. So you have all of those in files on your computer. And then down here, number 5, let's just look at it really fun. Let's see. We don't have to. But that's just, again, it's venture summaries. It's a directory with a whole bunch of summaries about people. And now you have a nice data set of everybody you're going to match against. And so the next step here is finding synergies. And in the synergies part, we're doing more prompt engineering with Cursor, or just prompt engineering in general. And the notion is that you have gone and created a set of data about something, yourself, for example. We have a set of data about something you're interested in, maybe a company you want to work for, or somebody you want to use their technology, whatever have you. And how do you determine what the synergies between the two of you? How would you rank that? And we'll look at that in a second. And so right now, we're at the very beginning of all this. But you can imagine the future when it gets better and better and better, it'll be like this really great sidekick of yours, which is constantly searching for synergies in your world and surfacing them to you. So let's dive into this one really fast. Where are we? This one here. And so this is in the repo that we have you guys download. There's the harvest one up there, and then I have an agentic match one down here. And the agentic match one down here, it's much more straightforward. It's not as agentic, towards the question earlier. And this one here, what we're doing is we're basically just having it go through, find all the files in whatever the respective directory is, hopefully from a smaller set, and then we actually have it run an inference from whoever you are against that file. And after it runs that, it generates these files over here, which is this little guy up here. And we have the, here's the member synergies, kind of fun one there. So this is, actually, let's go back 1 second. So what I did is I filled out the North Star worksheet, and from that, it generated this thing here. And this is like my company Matchwise. And what it did in here is it said, it's for people who network. It's my elevator pitch. Gets a good idea from there. We're very clear about what the problems are. Talk about the market opportunity, solution, the team, and some other references there. So there's a nice chunk of data available to it. And so we go back to the for my summary now. We look over here. We say member synergies. Let's see. Now we go back to here. Let's go back to members for 1 second. And so on the members from this before, we say here's the member summaries. Here's these guys here that describe their company. So if our prompt that harvested from the website described this pretty well, and if the other thing described me pretty well, then the question goes, what's the right prompt up here? Where are we? Match prompt. What's the right prompt to go and figure out if we're a good fit or not? And that's kind of the fun thing here. And that's, again, an exercise I'll leave to you guys here. Again, I just cranked out a pretty quick one here, but a classic one is a role at the top. You're an analyst evaluating potential business opportunities. One thing in here is when you're generating your prompts, even though we're not using real HTML tags or XML tags, AI is really good at using those to determine different sections of the document. So in here, for example, I said described as my profile. And then my profile down here below, I actually have some templating in here. So I'll take all that text from the markdown, I'll shove it in here. And then same thing down here, we have a company profile, exact same thing again, we shove the company profile in there. And we say in here, kind of the fun things. Again, I'm looking for any feedback from you guys. But here it's like, I said, create a list of concrete areas where the entities could collaborate, what have you there. General list of red flags. Why shouldn't we be doing this? And actually on this one here, for each red flag or hindrance, rate it how low risk or high risk this thing is. Maybe there's a better thing around that. And then lastly, we say, give an overall synergy rating. Based on everything you've seen, tell me if I should actually go and have a conversation with those folks. So this is a very simple, when you look at this at the end of the day, this prompt will be several pages probably, but for right now, it's good enough for the demo. And so based on this, when we did the matching down here, let's see, we dropped the answers into the directories here. So here's synergies, and let's look at Alina, this one here. And so what I had earlier, which was interesting, is I had a much shorter list when I did the prompt, and it was a very short list of synergies or bullet points I had in here. And the question is, maybe I should do a longer list. I'm trying to figure out, what's the right answer in here. Same with red flags, it has a nice long list of red flags. And then it gives me a score of 6 out of 10, which seems like pretty high for having all those red flags. But you can imagine that once it runs this kind of stuff here, that then you'd be able to stack rank the list of either people or businesses or whatever that you should talk to. You have, reasoned things to figure out why you should talk to them, and you can figure out who you'd actually want to talk to in the building today. Hopefully they're doing the same thing, they want to talk to you as well. So that's kind of the short version here. And you look at this, and this certainly isn't the only right way to do this. We talked earlier about using the RAG stuff. You might want to have a large database, like talking about the graph RAG stuff, is you might want to say, I'm going to pre-vet a certain set of data. Say, I'm looking for somebody within this who is a student who is looking in computer science, who is, who's looking for a job kind of thing right now. And you might want to pre-vet that data down to a much smaller set, so you use much less inference. But also, you might be able to get inference for free too, which is really interesting. Because your phone has a ton of inference on it. Apple Intelligence is really looking into how to spend that compute. One of the things I was thinking about is that at night when you go to sleep, you put your head down and hopefully sleep, your phone does nothing. You plug it in and it charges up and it sits there kind of thing. You have a GPU which does nothing all night long. And you look at all stuff like this here, say if we had a lot of inference for free, we could have your phone pre-vet every person, business, whatever you might run across in the next week, month, whatever have you. And it could then do these whole conversations here and come back with a list of people who you should probably go talk to make, whether it's your personal life better or your business life better. I think that's largely on this side here. So that was our finding synergies part. And I think so we basically did all these sections. You already walked them through. You generate your synergy from Agentic Profiles, one of the places there, and copy the markdown. We already did this. I think we're largely there. I walked through all this stuff. And then the same thing down here. Have you guys used any of the tools for using prompt improvements? Have you guys tried that yet? It's super useful. So the whole thing is I was totally converted about maybe 10 minutes ago with using tools like Cursor. It's my programming got massively faster. But there's so many things that can be applied to. When I tried to find the URLs here for the site, I could have written some code to go scrape them from the AI Alliance site, what have you. I just fired up Cursor and said, go figure this out for me. It figured it out for me, which is great, and got a list together. For the prompts here I was mentioning, you can ask the AI to help you figure out what you should be looking for to pull the data out to make better connections. So I would highly leverage that. And I think that's it. So if there's any questions, happy to answer those right now. If you want to, we can actually drop into the laptop part of this workshop where we actually break up in your laptops, team up with folks, look at the code, run the code yourself. So this we need to figure out. There's lots of pieces there too, and there's lots of people suggesting ways of solving this. So that's a great question. One part I'm very interested in is segregating or siloing your data based on who the agents are. So I think in your life you might have a health agent who knows about your health records. You might have a dating agent which takes care of dating stuff. You might have a business agent works on career stuff. You might have a family agent goes on and on and on kind of thing. And so you may just starting off decide to segregate your data based on agent. That's one part there. Then the second part is once the agent has the data and you trust it with a bunch of information about yourself. Actually, even that's complicated because some people work in the notion of data vaults, where you say, here's a third party has all my data, I've trusted them to read everything about me kind of thing. And then when this agent's operating, the agent might be able to talk to that data vault for you and say, I have this thing going on right now, maybe explain itself a little bit, and say, could you please release this and this and this? And kind of the fun things, there's the protocols are in really quick development right now. One of the notions, the cool things on A2A is that A2A can pause for as long as it wants, which is really neat. So the other agent can ask me some private information. I need to go ask the data vault. The data vault says, I need to get back in touch with the human now. I'm actually going to talk to the person and say, is it cool if this one accesses this chunk of data about me? So you can do these full human loop cycles if you want to. Yeah, and also, like we were talking before, the agent orchestration stuff is not just, there's not one LLM in there. It's a bunch of code there. And the code might look at it, might talk to the LLM and decide based on that whether to give access to this other set of data and pull it in order to build the context. So that might actually be human written code in there. So there's a ton of pieces. It hasn't been figured out yet, but we're in the middle of this right now. And again, you go back to the thing is if the more something that cares about us knows about us, the better we'll be taken care of. And it's the whole notion of the curated life kind of thing. Which is like right now, the fun thing is your life is curated by Facebook and TikTok and YouTube and goes right down the line there. It's you have these companies that found that your mobile phone has your attention all the time. They built these amazing apps to grab your attention and to use it to get you so you're able to buy things. And your life is curated largely by that right now. And I think the amazing opportunity here is that if we let agents that we control curate our lives instead of the agent of Facebook curate our lives will probably be better. And the agent might come up and say, you know what, you've been on the phone too long today. I will lose money by telling you this, but turn your phone off and go outside for a walk or something like that. So we're on the verge of this, which is really fun. And this stuff, I'm working in the UK right now with some companies over there, and the government very much wants this. The government very much wants to have standardized data for everybody, to put the standardized data in marketplaces. The marketplaces are actually how you spend your time. So like volunteering opportunities, career stuff, community events, what have you. And they want that data to be readily available. And now we're talking about using agents, and the agent will come in and look at the data. It knows you, and it says, "Oh, here's some ideas for you," and drive you into those very, very healthy activities. So we're on the verge of this kind of stuff right now, which is really fun. And it kind of, I don't know if there's a whole other topic is the notion is like, who are you? Because here we talked about your data. And most people, like, they take ownership. This is my data. I will present myself as this. But what's maybe better is that you should really be what you do, not what you say you are. And so one of the tools I like is think of OMI, which is really, really cool. OMI is a small pendant. I think there was B, which Amazon picked up. And the notion, it says that if I ask you who you are, you'll say something. But if I record everything you do, I will actually know who you truly are. So, for example, like if I'm recording your conversations, I'll see who you're short with, who you spend time with, who you laugh with, who makes your heart rate go up because we have tied into your Apple Watch, and I know a lot about you. And it might be different than who you say you are. And now I know who you are. Then we can look at all this other amazing data about what the opportunities are and surface them to you and drive them in a very, very healthy direction. So that's the kind of stuff. That's LifePath. That's another project working on in the UK right now. So super fun stuff there. Any more questions?
What's the major differentiation between producing low quality agent versus the high quality agent?
Yeah, that's a super fun thing. So what's the goal? I always start with the goal, right? And so the goal is, for example, you're a sales guy, and there's 10,000 potential sales leads, and you want to pursue them. And if you say, I'm going to use ChatGPT, GPT-5 or something like that on these, it's very, very expensive, and you'd use way too much money. So you might say, I'm actually going to use a much lower quality agent. And maybe even not an agent. Maybe it's something just looks at some basic indicators in there and vet from 10,000 people down to 100 people. And so for that problem statement, it might even be an agent. It might be something really, really simple. But I think that you and the market will decide when to use different agents for different things. Like on Cursor, for example, is that there's a flag there you flip that says, you pick the agent that I should use. Because some are very expensive for Cursor, and they have a hard time running a business with this. And lower cost agents, not lower quality, lower cost, which maybe is lower quality too, they can actually run a business with that. And for some of the things they're doing inferencing on, you don't really need a lot of smarts to do it. So, but I think at the end of the day, whoever is the engineer is going to decide what's the right agent, because at the end of the day, it's your business. And if the reputation of your business is being impacted by you choosing lower cost agents, then that's going to hurt you. And you might decide you have to use higher cost ones, but maybe it's too expensive, you go out of business.
So just to follow up on that, so if at my company, if I'm building an agent, which is like using the inference layer, not at the same capacity as ChatGPT and like Gemini, but at some capacity because we have some customer data that we have to protect in. So in order to build that agent, should we approach of OpenAI SDK and just create an app out of it and then just like connect that with ChatGPT, which is the enterprise version, and then run our agentic framework? Yeah. Or do you suggest something made on convert your custom tools as an MCP, turn up into the MCP, and that connected to the the OpenAIs and the Gemini of the world, and then start using those agents, because those are more powerful agents rather than just bringing the inference cost up and by building your custom agent in-house.
Yeah, and I think it's probably the right sizing the tool part, which is there's a ton of great tools out there. There's different parts time, but also there's the actual raw inferencing you're running. And a lot of times people, I think because models also have a bunch of other stuff strapped around them now. They have guardrails and all the other things that they're trying to figure out. And so you're actually not even talking to a model anymore. You're talking to a bunch of guardrails around it. And so for your business, I think you need to figure out, everybody does it here, is they say, here's my business problem. Here's the technology I come to bear on this. Here's the different models, different places I can run the models, different agreements with the model providers. So for example, like some of them will say, oh, every inference you run, we can keep the data and do training on it. Other ones will say, we have an agreement where we're not going to do it for you, have to believe them, kind of thing. Other people might say, I want to run my model, but only in infrastructure in my own building. It goes on and on like that, depending on what your sensibilities are. Yeah, and then on top of that, you mentioned all the tools. I think it's a whole separate problem, which is like, given you have a bunch of models to work with, what tools do you wire them together with?
My question is a bit philosophical.
Good.
I think what you're trying to do is basically to create a digital twin of yourself to do things that you don't like to do, or maybe save you time. For instance, speed networking, speed dating. Yep. But then that takes away the human side of things when you do speed dating or speed networking. And then when your digital twins agree that, oh, we actually a good match, then the next day it's you and me face to face. We actually need to sign a deal.
Yep.
But I actually don't know how my agent reached that conclusion that we are a good match.
Yep.
Especially in dating, obviously.
Yep.
So I'm a lecturer myself. So when I design assignments, when I mark assignments, I often think, am I coming up with this assignment, or is the digital twin behind my brain coming up with this assignment? Is the student doing the assignment, or is the digital twin behind the student doing the assignment? Is this conversation between me and the student really a real conversation, or is it two agents talking to each other?
Yeah.
And then you're getting a score out of it. Is it really helping you learn, helping me as an educator? Are we creating any value at all? And I want to throw that question at you. When you replace the entire speed dating networking with two agents talking to each other, is that really a human process? Thank you.
That's awesome. So did you see Hang the DJ? Did you watch that yet? So this is a Black Mirror episode. Hang the DJ, I won't ruin it for you, but it's the episode, and it's about these two, a guy and a girl, and they're going on a gazillion dates. And they're repeating over and over, and different people, whatever, all these different scenarios. And you're all, this sucks, it goes on and on and on kind of thing. And why are they exposed to very different outcomes or different dates? And at the very, very end, the reason's obvious. It was a simulation. And they were told the right person to go to. And so, but the question is like, what's the goal? Is it, for a given thing, there's a bunch of stuff that can be automated, whatever it is, relationships is one of them. And if I said in this room right now, you might have a handful of matches in this room right now, is the best way you spend your time today to talk to every single person here? It's going to take a massive amount of time. Or can I save you a whole bunch of time? And maybe it's not the perfect 10, but out of that 10, maybe the higher probability is 3 in there that might be good people for you to talk to. And so is that the goal? Is to really save you time? Because for me, it's I want to go to an event like this, and I miss talking to awesome people all the time because I couldn't find them. It just wasn't obvious. So I'd love that part of automation on there. What was the other thing you said? The humanness part. What's the goal though? It's so one of the things that they talk about a lot with automation is it says, we're going to lose our jobs. We have 8 hours of work a day or whatever it is. We're going to get 2 hours of work. And it's not about losing your job. I just gave you 6 hours to do something really useful with. And the 6 hours could be meeting the right people. So you could either spend 6 hours talking to the wrong set of people, or you could spend 6 hours with a really amazing set of people. And I think that goes back to what we were talking before, is a curation of life. Is I would like to imagine, in the future, is that your phone every week nourishes your friendships, nourishes your businesses, and says, hey, there's this cool person. And it doesn't have to be a relationship. It can be anything. Just go talk to them. And every week, if you do this, it just turns out you run across interesting people. And out of that, you end up with your friend group nourishes itself and is always pretty good. Whether there's the dating, there's business across the board on this. And I think that's the future we really I'm super looking forward to.
So I totally love the idea of having 6 hours of my life back if we're not going to, create a 36-hour day. But when billionaires, not that you're a billionaire, but recently the CEO of Robinhood got up on stage at TED and said that it's going to be totally fine. We've been losing jobs for thousands of years. There's always new jobs. But I guess my question is if I'm only going to get paid for 2 hours and it's the same wage or a lower wage, it's very difficult for the CEO of Robinhood, who has $4.2 billion to his name, to tell me that it's okay, I'll have another job, but that job might pay 0.001 cents, right? So there's the question of identity. What is my identity? I'm an engineer, but I'm no longer an engineer if I can't work or afford to compute. And then 2, if I go from, say, making 100K to less than $1 a day, how is that problem solved?
All right, I love this stuff. All right, well, it goes in an interesting direction for you. So 2 things in there. One thing is purpose. You touched on a bunch of stuff there. One is purpose. I think having purpose is amazing. And I think also with these systems, the Life Path stuff in the UK, it's helping people find purpose. I was talking to a guy at an event maybe 2 or 3 months ago, and we were having this same discussion here. And he was actually writing an app to help people find their purpose so they're happier in life. So I think that's one whole problem state that needs to be solved, 100% on that one. I talked to another set of investors, this was maybe a year ago, and we had this whole dystopian version of things, which says we start replacing people with automation. And there's I'll give you the backstory on this. The backstory is it was the 1740s or something like that, whenever it was. Over 90% of Americans were farmers. We all lived on farms. And over the next 60, 70 years, whatever, it converted down. It's 30% after that. So it's not even a double. We have a single source coming down now, which is one thing is that happened over a long period of time. We did not have automation then, so it made sense that people would move to the cities. And we would create new jobs for them, which ended up being like baristas at Starbucks and stuff. And so we all loved that, and a whole bunch of new jobs we really, really enjoy. So that made sense. It translated over really nicely. So one is over a long period of time, and there's a set of jobs that the only thing you do is humans. And so that's where we are with cities right now. The thing you're running right now is that we're looking at automation replacing a lot of that human stuff. And that might happen over a very, very short amount of time. So that's something to be worried about right now, 100%. So yeah, total dystopian on that one, but I think it's going to happen. But I talked to a bunch of investors about a year ago about this and said, hey, what's going to happen? And what they said is they worry about two things. They worry about revolution. If everybody's very unhappy, they might revolt and your government collapses. So they definitely don't want revolution. And they worry about crime. Is that if everybody doesn't have money, you steal a lot. And I've been to other countries like that where there's very, very, very high fencing costs. You go to places it's just not safe to go there. And so we don't want to live in a country like that. So the billionaires don't want to live there either. And so what they said is this is it's not all of them, but they said high taxes. And they said they'd be willing to accept extremely high taxes and do UBI. So now we can do your 2-hour day, we can give you money to get by, you can live a reasonable life kind of thing, and we will support that. And the problem you get into is riding the dystopian wave right now. It says if a country adopts that set of policies, that's very resource intensive, that we're supporting a large population that's not working, and your neighboring country might spend that on something different like weapons. And so what happens when our neighbor is weaponing up, whatever, and we're having a great time here, and then what do? So anyway, fun stuff. Good question. Thank you so much.
Hi, thanks. So I had a question about. So I'm a little embarrassed to admit that I've still been doing AI-assisted coding by just, I have ChatGPT open. I say, very low level, give me a function that does this.
Yeah.
I'm still doing that, and I think you just sold me on I got to get on.
Oh, you got to do it, 100%.
Yeah. So how did you choose Cursor? How did you figure out the tool chain you like?
I just asked some people. I did it really bad. I asked some people. They said it. I went online. It said to do this. It seemed like all the data is pointing in that direction. I started using Cursor. There's other really good tools too. If I was really trying those also. It's the whole sharpening the axe thing, and I'm not sharpening my axe right now. Cursor does really, really well for me. Thank you, Cursor.
Okay.
But there's probably ones that are really, really good. Sometimes I run, there's like Claude. I think Claude has the plugin of Cursor, so you can run it in a window also. You have to compete with each other. So stuff like that's good. I think you should always be competing.
Cool. Sorry, one other little follow-on question for that. So I'm a professor of computational chemistry.
Oh, cool.
So I'm teaching my students to code all the time, and the perspective I have is, someone's been coding over a decade, and I learned how to do it without having an AI, to lean on.
Yeah.
And I worry that students are they're not going to know, they're just prompting and asking for things, and it's producing code that they're not sure what it does.
Yep.
So I think it's great for people who have been around for a while. This is amazing. We can get so much done, and we know what the code does because we know how to read it. So what do you think about all that?
Yeah. So one thing's technical debt. I see this a ton. Is people go start vibe coding something, and into that vibe coding, but it's just a spaghetti junk. And even the AI is having a hard time unwinding adding additional features for you. And you as a software engineer, you would have caught that really early. If you had a team member adding junk, it works, the screen looks correct, but under the covers it's still junk. You would have caught that really early in the review. And so I think on mine, I code a lot, and I look at my code, I review every line of code the AI does. And sometimes it'll start doing something just going in the wrong direction, and I'll actually have to pull it back. And so it's a whole speed thing. I think overall I get massive improvements, but sometimes you get stuck in a rabbit hole. You might take an hour or two to unwind something. And sometimes it actually can issue stuff too. It gets stuck on that too. So it's not a panacea for everything. So, but cool stuff. Thank you. Cool. Thank you, everybody.